And good night, my friends. I bet you're wondering what took me so long. Well, school started and I initially got really busy taking care of administrative stuff, but enough of those boring details. I've come to bring to you something even more boring than you could ever imagine. College Calculus 1. And it's not just regular calculus either, it's mathematics for technology B. So I don't think they use all of it, but they use enough for it to be seemingly terrifying. But I'm gonna let most of that speak for itself. So the official name is Mathematics for Technology B. So, by the look of the syllabus right here, they cover limits and continuity, differentiation, maxima slash minima and tangent slash norma, integration, differential equations, determination of laws, vectors, and complex numbers. Doesn't that sound fun? But with this being the official first class on the 16th of January, first we went over the coursework for the class. We have 2 tests and 2 assignments. Test 1 and assignment 1 add up to 25 marks, 20% and 5% respectively, and test 2 and assignment 2 are 10 and 15% respectively. Throughout the semester, from now until the end of March, these 2 things will be done. And we're given more boring details like exam breakdown, textbooks, but I'm not gonna bore you with any of that stuff. We're just gonna move on to the first topic which we covered for this evening, which was limits. Oh dear Lord, limits. So basically, we weren't given a set definition either, that or I wasn't paying enough attention. But from what we were told, we have to see it as the limit as x tends to a, and a is a number. So let me write it here. Limit as x tends to a. Whoops, come on A, not anarchy. So let's use a quick example. So we have the limit as x tends to 3 for the function x plus 3. You know, I forgot to include that, but it's not too late. Whoops, why? X plus 3. Limit as x tends to 3. That's better. So, moving on. So from that same example, so for that same example, we have the limit as x tends to 3. We say x plus 3. But in this case, since x tends to 3, we can replace the x here with the number 3. So we can say 3 plus 3 is equal to 6. 6. Smiley face. Because I'm like that. Alright, so we were also introduced to the concept of an asymptote, where we have a value approaching 0 from the y-axis and infinity from the x-axis. So let's represent that as a graph. So we have, yes, okay, we call this the y-axis, and oops, I keep doing an anarchy business. The y-axis and the x-axis, and we have a set of numbers here on set of points on this graph going from y down to 0 or infinity. Wait, it's x to infinity, my mistake. So basically we have a bunch of points on this graph and they're approaching, but it doesn't get there. It never touches it, but it gets really close the further along you go. Where x is approaching infinity, we have where, let's just say we have a limit where x tends to infinity. 1 over x squared is equal to 0. Where the limit as x tends to infinity, we have 1 over x that's equal to 0, and we have the limit, you guessed it, as x tends to infinity, where 3 over x cubed is equal to 0. And now we evaluate some examples. Whoops, that v doesn't look right. So here we have, for the first one, we have x squared minus 16. So what we do here is find the we break this down into the multiplication of two squares in bracket. So we say x plus 4 and x minus 4. That's sort of 4. And I bet you're wondering how this works. You know the FOIL thing, FOIL, first, outer, inner, last. We're gonna basically do something like this, then this, then this, then this. Let me show you. This is just to show you how we get this equation from, no, it just goes to explain how we get this expression from this expression to complete the equation here. So x times x is x squared, x times 4 is 4x, 4 times x is 4x, the minus sign here because this is a negative 4. 4 times 4 is 16. So the first thing you realize is that these two 4x's cancel because one is positive and one is negative. And that's how we get x squared plus... Wait, oh, hold on. This can't be a plus because this 4 here is positive and this one is negative. And because they were multiplied, we get negative 16. When you multiply a positive and a negative, you get a negative, so that's negative 16. So as we're saying, these two cancel, so these two go away. And that leaves us with, this cancels with that sign. So this leaves us with x squared minus 16. And that's where we get it from. Sorry to move so quickly. So we're going to do something similar with the second example where we have x minus 4, and that's equal to, we have in bracket the square root of x minus 2 and the square root of x plus 2. pair these off for now, paired, because that's how I have them in my notes. And I am a novice, thank you very much. So here at number 3, we're going to do something slightly different. We're going to have 3 numbers. We have x squared plus 5x plus 6. So here we need to do what we call an AC rule operation, where we have to multiply. Let's just say this is A, this is B, and this is C. To complete this AC rule, we need to multiply A. We need to find a set of numbers that multiplies to get C but adds up to get B. So we need to find the multiples of 5 and 6. Now the multiples of 6 equal 1, 2, 3, 6. Okay. Let's just say we'll multiply 1 by 6. That's equal to 6, right? So that checks out so far, but let's add them. So we have 1 plus 6, we get 7. Now we know that can't work, because 1 plus 6 is not 5 in this case. So we have to try something else. We can do 1 times 2, but that's equal to 2. 1 plus 2 is 3. That works for neither of them. We can do 3 times 6, but that's 18. That's way out of the range for both. 3 plus 6 is 9. That does not work. Boo. So that leaves us with 2 times 3. We get 6. That checks out. 2 plus 3, we get 5. So we have something to work with. So now we have x squared plus 2x plus 3x plus 6. And we can expand these to put them in bracket by factoring the x from one side and the 3 from the other. So the reason why we do that is because we need to end up with the same expression in the brackets. When I say that, we need to end up with the same expression in the brackets. So let me explain. We have x plus 2. We need to get this on this other side as well. So we need to find a number that divides into this section to give us this in bracket. So that's why we use the 3. Let's just say we say plus 3 bracket x plus 2, because 3 times x is 3x and 3 times 2 is 6. And that's equal to x plus 3 and x plus 2. So to repeat, for x squared plus 5x plus 6, we have to multiply to get 6 like on this side, but add to get 5 here. And we went through the possible combinations for the multiples of 6, and the only 2 we could get were 2 and 3. So from there we said x squared plus 2x plus 3x plus 6. So we put these values in this new expression on this side of the equation. But we're not finished. So what we had to do was we had to expand these further. So we had to factor out what would go into this here, this here, this here, and this here. So what we do, imagine these brackets. And we had to factor these 2 different parts. So we can say from here, we have to find the like terms in each bracket to ensure that we get the same, whatever you call this part here again, on both sides. So we can say x multiply by x plus 2, because to get the x squared, multiply x by x. To get 2x, and multiply x by 2. And the same thing here for plus 3, but we want to get the same thing in this bracket, and that's how we end up here again. And we're going to do something similar for number 4, running out of tablet space. So for number 4, we have 3x squared plus 7x plus 2. This time we need to multiply values The tricky part here is you'd initially say that, but isn't 2 times x just 2? But here's what you need to consider. You have the 3 here and you have the 2 here. The way the AC rule works is, let's just say if this was 2x squared and this was 6, we'd have to multiply the a by the c, which is the 2 times the 6, and that would be 12. So then that would mean that we had to multiply to get 12 but add to get 5. So if I didn't mention that before, I apologize. So to continue, we need to multiply, we need to find a set of numbers that multiply to get 6 but add to get 7. But based on the previous example, we realized that 1 times 6 is 6, but 1 plus 6 is 7. So we'll just go with that for the sake of simplicity. So we can say 3x squared. That's not a square. 3x squared plus 6x plus x plus 2. So to simplify this even further, we need to factor out 3x on this side and x on this side. No, wait, not x, but 1, because we still need the x. Let's just say 3x. So we have x plus 2 again. And on the other side, we have plus 1, x plus 2. We use the 1 here because we want these two in bracket to be the same, but because we have them already, we wouldn't want to change it. Because whenever you divide any number by 1, you tend to get that number like 3 divided by 1 equals 3, 2 divided by 1 equals 2, 0.5 divided by 1 is equal to, well, 0.5. But that's beside the case. So for this example, we would get, you guessed it, 3x plus 1 bracket and x plus 2, and that ends question 4. And then we went right into the limit laws. This is a very quick-paced class I had just a while ago. I'm actually doing this to help as a study aid so I can cement the terms into the back of my brain so I don't have to cram last minute, like some poor experiences I had in previous semesters. But if you're with me this far, I'm sorry for boring you, but I have to really get through this. I feel determined, I feel brave, and a little bit like I want to find something else to do, but I don't want to put this off to the last minute because I'm worried that I won't be able to remember it if I don't practice it enough. I also got a worksheet. I ain't doing that yet. Pencil. But maybe I should. 'Cause isn't that the purpose of all this? philosophical stuff. So we have the limit. We have the limit. We have the limit. Oh, wait. Oops. Oh, oops. Does it work now? Yes, it does. Close that. We have the limit where x tends to a for the function f is equal to f, and we have the limit. That's not how you spell lim. Darn it, where x tends to a for the function g of x is equal to g 1. So we have the limit where x tends to a. I'm gonna say x tends to a lot, aren't I? This is annoying. For the function k times f of x is equal to that number k times f. So as an example, examples are fun and makes me want to draw, and wonder how you draw that Konata character from Lucky Star. Whatever. I'm getting into nerdy stuff right now, so we're gonna leave that for later. So as an example, we have a limit. The limit x tends to 2 for a function 3 times x plus 4, and x plus 4 is f of x. So I was instructed to say 3 limit x tends to 2 where x for the function f plus x plus 4. So that's 3 limit where that's limit x tends to 2 for the function x plus 4. What we were told to do was we're supposed to put this 2 where the x is here. So we can say 3 2 plus 4 is equal to 3 times 6, and that is equal to 18. 18, Android 18, some stuff 18, you're 18, happy birthday to you. Snap, I'm so tired. And that ends with that example. So we move on to another. Limit x tends to 2, no, it tends to 1 this time, for the function 2x times x plus 1. So in this case, let's call 2x f of x. Let's call x plus 1 g of x. So in that case, we have to submit where we see x everywhere. We have to say x is 1. So we say 2 open bracket times 1 where x was, open bracket, 1 again, plus 1, close bracket. So we can say 2 times 1 is 2, open bracket, 1 plus 1 is 2. So that's 2 times 2, and 2 times 2 is 4. Fun, excitement, calculus. So we continue with a case. I know I don't mean a briefcase, I don't mean a suitcase, I don't mean a criminal case where people go to court and talk about stuff. I'm not talking about a sandbox where you throw your children. Wait, that's a terrible thing to say. Sandbox, child, little bucket, one of those shovel things, more sand. Oops, it doesn't go that far. Oh well, look like me I draw one house. Draw one little house. One little door. I want a spider look through the window. So anyway, we have a case where we have a limit x tends to x tends to a, I'm sorry, for the function f of x, g of x. We're basically just multiplying them here, so we say f times g. And that brings us to example 3. Example 3. 3 is not a nice number, isn't it? So limit of x tends to a, where open bracket for f of x plus g of x. That's not how you write a g, plus g of x hold on a second, cancel this. Open bracket f of x plus g of x, close bracket, is equal to, guess, 4 plus g. So let's put this into an example. Limit x tends to 2 for open bracket x plus 3 plus x plus 1, close bracket. And as usual, we have to put a 2 from this limit where x is. So we can say, open bracket again, 2 plus 3 plus 2 plus 1. And that's equal to, so 2 plus 3 is equal to 5, plus 2 plus 1 is 3. So now we say 5 plus 3 is equal to 8. Example 4. A couple years ago when I was a young lad, I watched this show called The Hitchhiker's Guide to the Galaxy. And there isn't a lot I remember from it, but one thing I remembered, I don't know the actor's name or the role's name. Well, I don't remember. But I remember hearing something where they said 4 is the answer to everything or something like that. So, let's see where this goes. Let's prove them wrong. So the limit x tends to a for f of x minus g of x. Why do I keep doing that? Stop. This time we say, you guessed it, f times subtract g. So you know, if g was here and f was here, we'd say g minus f. And as usual, we're going to go to the good old example. So we're going to say the limit x tends to 2 for f of x minus f of g, or f of g, g of x is equal to f minus g. And that's equal to f of 2 minus g of 2 is equal to let's see. Hold on a second. You remember that thing I wrote earlier Let's go back. X plus 3 and x plus 1, do you remember that? Do you remember that? Do you remember that now? Yes. You see how far that's coming from? That was my bad. So let me write it from now. So for here, f of x is x plus 3, right? And g of x is x plus 1. That is for number 4. 4 is the answer. Or is it? So right here, notice how we have f of 2 and g minus g of 2. So here's what we're going to do. We're going to apply these functions to this limit. So we're going to say x, which is 2, plus 3, you with me, minus 2 plus 1. And then we say 2 plus 3 is 5 minus 2 plus 1, 3. And that's equal to 2. So we proved them wrong. The answer to life is not 4. Well, maybe it's not 2 either, but we got the answer. Ticky, smiley face, knowledge. And we move on to number 5. Number 5. Limit where x tends to a for the function f of x divided by g of x, that's equal to f divided by g. So then we're going to apply it to an example again, and we have limit x tends to 2 again for the function x plus 3 and x plus 1. And let me mention something here real quick. As a rule of thumb, where limit x tends to a number, you always have to rewrite this unless you're putting the number in the equation. So in this case, you'll see me say 2 plus 3 because I'm putting it there. If I were to do more work on this section of the limit, I would have to rewrite this limit here and show how I expand this section. So anyway, we're saying 2 plus 3 divided by 2 plus 1. So we're saying 5 divided by 3. And this is okay, so we're just going to leave it there. And continuing, we have this thing that caused a bit of an uproar in class, and it's called the indeterminate. That's indeterminate. Determinate. Yes, determinate. Or it's just a thing that says that we should do more work if we get an answer like 0 over 0 or infinity divided by infinity or infinity subtracted by infinity, or you get what I mean, Visio. And here's where the headaches kind of came in for me for the first time in calculus this evening. So let's just say we have a question. Limit x tends to 3 for the function x squared minus 9 over x minus 3. Immediately if you can tell where this is going, some strange things will be happening. So we're substituting 3 where x is. So we're saying 3x minus 3 squared minus 9 over x minus 3. You can immediately see where we're going with this. 3 squared is 3 times 3, that's 9 minus 9 equals 0, and x is 3 minus 3 equals 0. So we ended up with 0 divided by 0. At this point, we were told to do more work, but how, you ask? We look right here, and we are going to factorize the numerator. How do you ask? If you're at this point and you don't know why, good. We're gonna start the question from scratch. And we're gonna say the limit x tends to 3 for the function x squared minus 9 over x minus 3. Disney. So you remember that thing, that very first question we did? Let's go back and take a quick look. The very first question. This one. You see where x squared minus 16, and we expanded to include the two squares so we could FOIL them. Well, that's basically what we're going to do down here again. But here's what we're going to do to the numerator this time. We have to say the limit x tends to 3, and because we're expanding this, we say x minus 3 and x plus 3. Over x minus 3. What immediately happens here is that we have to cancel these two here because they are like terms. And that leaves us with limit x tends to 3 for the function x plus 3 simply. So now, since we have this, we can simply put 3 where x is and say 3 plus 3 equals 6. It took me 3 minutes and I didn't figure this out in class before this was explained to us. Oh, that teacher is a terrible lady. And that's only one. And she said that one's easy. So now we're going to move on. Take a moment to look at this and make your notes if you have to or if you have been. I'm just hoping that this helps out anyone else, because my teaching skills aren't 100, but I understand this enough to want to share it with others, and I know I'll make mistakes, so don't be afraid to point it out in the comments if you happen to see this, and I'll get back to you on that note. And we'll be moving on to the next one. If you didn't pause before, you can go back a couple of seconds and pause if you have to go through it, look at it, and analyze it. But for now, we're going to continue. And number 2. Limit x tends to 3 for the function x squared minus 5x plus 6 over x minus 3. So we follow the usual process, and we're going to say 3 squared, because we put 3 where the x is, minus 3 plus 6 over 3 minus 3. So you'd say 9 minus 15 plus 6. That equals 9 minus 9, because 15 plus 9 is negative 15 plus 6 is 9, over 0 equal 0 over 0, and we cannot have this. So what we have to do is we have to go back here and figure out what we're going to do to it. And here's what we're going to do. We are going to use the AC law on the numerator here. So we're going to rewrite this question. Limit x tends to 3 for the function x squared minus 5x plus 6 over x minus 3. So we're going to say limit x tends to 3 for the function x squared minus 5x plus 6. But because of the AC rule, what we have to do is we have to now find a number that we have to find a set of numbers that multiplies to get 6 but adds to get negative 5. Pay attention to the negative. And for the purposes of saving time, we're just going to go and say you have negative 2 and negative 3. So we're going to say the limit x tends to 3 for the function x squared minus 2x minus 3x plus 6 over x minus 3. And here's how it's going to go. We're going to expand up here. We're going to expand up here a little further, and we're going to factor out the x on this side, and we're going to factor out I made a mistake. This should be the 3 and this should be the 2, because take a look at this. We need to have some sort of balance here if we plan to get rid of this properly. So here's what we'll do. We're going to switch these numbers. Notice how this is a 1x, this is 2x. We say this is 3 and this is 6. So this is how we kind of maintain a balance. So in expanding this, the limit x tends to 3 for the function x minus 3 minus 2 x minus 3 over x minus 3. And we're going to go even further to complete that expansion on the numerator by saying the limit x tends to 3. I'm the worst. X tends to 3 for the function x minus 2 and x minus 3 over x minus 3. And immediately we notice that these two parts here cancel, leaving us with, you guessed it, limit x tends to 3 for the function x minus 2. So at this point we've gone from x squared minus 5x plus 6 to simply x minus 2. So then we're going to just continue at this point and replace x with 3. So we can say 3 minus 2 is equal to 1. Oh yeah, and in case you're wondering, I am not breaking up this video into parts. It's all or nothing. Go hard or go home. All of this was done in a 2-hour period. Well, I should probably break this down. I should, shouldn't I? Will I break it down? Okay, future me, you decide. Just put some text where I'm saying this, deciding whether or not I decided to split up the video. Wait. So, take some time to get this section down. You can pause here to get this part. And you can pause here to get the rest of it. Remember, this is 3 and this is 2. Okay, let's continue. Alright, so this time we're going to do something a little different. Number 3. Limit x tends to 4 this time. Sorry. Limit x tends to 4 for the function the square root of x minus 2 over x minus 4. And we're going to say the limit. No, we're not. We're going to say, since x tends to 4, we're going to say the square root of 4, that's not a 4, 4 minus 2 over 4 minus 4. How this works is we're going to say the square root of 4 is 2 times. So we're going to say 2, subtract 2 over 4 minus 4, and that equals 2, 0 over 0 once again. Notice how this looks like a percentage? Well, it's not. You know, I'm not gonna lie. This subject can be boring. Boring, 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 boring. But it depends on you. So let's approach it a different way. We can't get this, we can't use this answer. Smiley face. So what we have to do is that we have to look at this again and decide what we're going to do with it to get the answer we need. So what we're going to do, we're going to have to factorize the denominator. So we're going to start from the beginning. Limit x tends to 4 for the function square root of x minus 2 over, you remember what we did earlier with the x squared minus the 16? We're basically going to break this down further. So to break this down further, we need the square root of this squared and the square root of this squared. So we're gonna say the square root of x squared minus the square root of 4 squared, so that's 2 squared. So because we do this now, what we do at this point is that we can expand this, we can expand upon this, and we'll say that limit x tends to 4, where the square root of x minus 2 over square root of x minus 2 and the square root of x plus 2. Notice what happens is that these two end up being like terms, so we have to cancel those. 4. When we do that, we get limit x tends to 4, where for the function 1 over the square root of x plus 2. So now we can put the number 4 in the equation, in the expression to complete the equation. So we say 1 over the square root of 4 plus 2, that's square root of 4 plus 2, not the square root of 4 plus 2. The square root of 4 space plus 2. We're going to say 1 over 2 plus 2. We're going to say that's equal to 1 over 4, a fourth. And you can take a moment to write that one down and analyze it. I'm not gonna lie, I didn't get that one first myself. So go ahead and take a moment, pause if you must. That's not an M. Yes. And we'll continue again. No, that's redundant. And we'll continue. So now we're going to go to number 4. And please don't hate me for this. Limit x tends to, guess what it is? Is it 5? No. Is it 4? No. Is it 2? No. 0. The limit x tends to 0 for the function, open bracket, x plus 1 square minus 1 over x. And you're like, Ryan, what the heck, man? So you'd continue to put 0 where you see x to say 0 plus 1 square 1 times 1 equals 1, subtract 1 over 0, and you get 0 over 0. See, 0 plus 1 is 1, 1 squared is 1, that means 1 minus 1 is 0, and you have x equals 0, so that's 0 over 0. And we don't want this answer. We want something else. So we have to figure out what to do. What to do. We are going to, you want to guess? Factorize? No. We are going to expand and not blow up. Expand. Limit x tends to 0 for the function x tends to 0 for x, that's an e, x plus 1 square minus 1 over x. We're going to expand the numerator. And how we're going to do this is that we're going to say x, the limit x tends to 0 where limit x tends to 0 for the function let me check that again. Yeah, I had that right. Limit x tends to 0 for the function x plus 1 and x minus 1. Or is it x plus 1 and x plus 1 because it's squared over x. So what's going to happen is that we have to use the FOIL method on the numerator to further expand on this. So we're going to get, maybe I should bring this to the top. Oh man, it's been 56 minutes already. Oh man. Limit x tends to 0 for the function x times x is x squared plus x plus 1. Not 1 square, just 1 over x minus 1. Let's not forget the minus 1. So let's go up and go through this part again because it's important. The limit x tends to 0 for the function x square, x plus 1 square I mean, minus 1. This minus 1 is important, don't forget it. You know how SpongeBob says, bring it around town, bring it around town. Stomp on your right foot, don't forget it. Well, this is a moment. Square the x plus 1, square the x plus 1, step, don't forget the minus 1. So we're going to say, since we can't forget this, and we had to expand, we say x plus 1 times x plus 1, because it's squared, minus 1. So we have to say, since we're multiplying like this, we have to use FOIL. X times x is x squared, x times 1 is x, 1 times x is x, and 1 times 1 is 1. Minus 1. Step on your right foot, don't forget it. So now, we're going to begin with the simplification of this. So we're going to say the limit x tends to 0 for the function x squared plus 2x, because we have 2 x's, so we'll put the like term, add the like terms together, plus 1 minus 1 over x. So this part now will be eliminated because 1 minus 1 is 0. Limit x tends to 0 for the function x squared plus 2x over x. And right now we can expand on this. Now we can factor this for x and say limit x tends to 0 for the function x plus 2 over x. At this point, we have like terms x and x here, so those cancel. And we're reduced to limit x tends to 0 for the function x plus 2. Would you look at that? Now we can put 0 where the x is and say 0 plus 2 equals 2. And that's the beauty of limits for you. Look at all that. If you weren't following, I'll give you the time to write it down if you wish. I'm gonna pause here and write down what you need. And when you're finished, unpause and continue. Make a little mark. You ever been in grade school and you're looking at the chalkboard and you're writing off something you didn't get the chance to, and then someone just comes and rubs it off and you say, "Why'd you do that?" "I was still writing." Then they look at you and say, "Tough luck, it's a cold world." I'm just kidding. Someone probably lent them their notebook or something. I know someone lent me. So now you can pause and get this part down. And we'll continue. If you hear any background noise, I apologize for that. And now we can continue with example number 5. Alright, so we're back. I finally decided that I should just record it one time and just be done with it. I know it's kind of late, but we're going to finish. We are going to finish. So last we left off, we were going to begin with number 5, where we have limit x tends to -4 for the function x squared plus 8x plus 16 over x plus 4 square times x plus 1. So we can actually do this either way. We can expand the numerator, or we can factorize the denominator. So for the sake of this example, I'm going to do both, and you'll see what I mean. So first off, we're going to deal with the denominator. So limit x tends to -4, where x squared plus 8x plus 16 divided by x plus 4 x plus 4 and x plus 1. So before we continue this, let me show you how it would have worked out normally. So if we replace x with -4 with the equation up here, we get -4 squared plus 8 -4 plus 16 divided by -4 plus 4 squared and -4 plus 1. That would equal to 16 plus negative 32 plus 16. And that would be equal to, wait, over 0 square times negative 3. And that would be equal to 16 plus 16 minus 32 over 0 square minus 3. And that would be equal to 0 over 0 minus 3, and that's equal to 0 multiplied by negative 3 equal to 0 over 0. So going back to our expansion, we're going to continue and say the limit x tends to negative 4 for the function x squared plus 8x plus 16. We FOIL right this up, we FOIL right here, so we say x squared plus 4x plus 4x plus 16 x plus 1. We continue with limit x tends to negative 4 for the function x squared plus 8x plus 16. Then we have to add these two 4x's, meaning that we have 8 x's in all. So we got x squared plus 8x plus 16 times x plus 1, and these two cancel, so we end up with limit, what am I doing, x tends to negative 4, so we get negative 4, no we don't, we get 1 over x plus 1. And that equals to 1 negative 4 plus 1 equal 1 negative 3. 1 over negative 3 equal to 1 negative. That's basically what you get for the answer here. You know what? I'm gonna do the other one too. Well, basically if we're up here, what we have to do is that we have to multiply a set of numbers to get 16, but when we add them, we get 8. So what numbers can we multiply to get 16 and add to get 8? 4. So that would be x squared plus 4x plus 4x plus 16. We're basically doing the inverse to get these two values here, and then we'd cancel those. And we basically end up with the same answer because we still have the x plus 1. And we approach number 6 with extreme caution. So for number 6, limit x tends to infinity. This is where the madness begins. For the function 2x to the 4th power times x squared times 8x. Well, in the case of a limit when we're dealing with infinity, we always look at the highest power first when dealing with infinity. What that means is we're going to divide each part of the expression by the highest power, and then we're going to work it out from there. So you can just use this part as a reference, where we're going to say limit x tends to infinity for the function 1 over x equals 0. Limit x tends to infinity, where 8 divided by x to the 5th power is equal to 0. So 8 to infinity is equal to 0. We were told to remember this part. We needed to remember it for some reason. So we're going to continue with that last problem. So we say limit x tends to infinity for 2x to the fourth power minus x squared minus 8x, and that equals to, just because it's infinity doesn't mean we don't know the number. We have to treat it like how we've treated the other numbers in the past, where we replace x with infinity. So we're saying 2 infinity to the 4th power, or as my friend Buzz Lightyear once said, to infinity and beyond, minus infinity squared minus 8 times infinity. But this is going to be an insanely large number. We don't know this number. So here's what we're going to do. We're going to re-establish this and work our way from the foundation all the way to the top. So the limit x tends to infinity for the function 2x to the 4th power minus x squared minus 8x. So we have to factorize. Let me write it down. Factorize x to the 4th power in this expression. That simply means we're going to divide everything by x to the 4th power. So we're going to say limit x to infinity. That's not how you do it. To infinity tends to infinity for the function 2x4 minus x squared minus 8x divided by x to the 4th power here, x to the 4th power here, and x to the 4th power here. And I bet you're wondering, how in the world is this going to work? So I want you to open up that part of your imagination inside this bracket, and we're going to look at the x squared, because these two cancel even the 2. So imagine you have x squared divided by x to the 4th power, and you're wondering, how in the world am I going to do this? Well, imagine that since this number is being squared and this number is being to the 4th power, it's going to represent how many times you're going to multiply the number by itself. So you're saying x times x, and you're going to say for x to the 4th power x times x times x times x. That's 4x. You're going to cancel those that are there and leave the ones that aren't, and you're going to say you're going to end up with 1 over x times x, that is x squared. So in the other section of your imagination, I want you to look at the formula for 8x. So 8x divided by x to the 4th power is equal to 8x divided by x multiplied by itself 4 times. And you're going to lose 1x because they're still like terms. And you're going to end up with 8 divided by x to the third power. X to the third power. And that brings us to continue here. So the limit x tends to infinity for the function 2 minus 1 over x squared minus 8 divided by x to the third power. 8 divided by x to the third power. Yes, I said it. X divided by you hear me? X divided by, you hear me? 8 divided by x to the third power. So you notice what I did here, this is not entirely correct. We're cancelling one of them, so we're still gonna have x to the fourth power right here, and we're not gonna get 2, we're gonna get x to the fourth power. So now we can substitute infinity into the equation by saying infinity minus 1 over infinity let's not do it that way. Let's factor x to the fourth power out of this equation. So we're going to have another step saying limit x tends to infinity for the function x to the fourth power bracket 1 minus 1 divided by x to the second power minus a divided by x to the third power and now we can continue that way. Hold on. Now we can continue. So we say that's equal to infinity, to infinity times 2. And that's equal to infinity. And I bet you're wondering, but Ryan, how does this make any sense? Well, let me tell you how it makes sense. Let's break some ice and establish something for me. If you have a calculator, I want you to take it out real quick and do these calculations. Make a note. So the limit x tends to 0 for the function 5 divided by x, and that's equal to 5 divided by 0. And we have a next one. The limit x tends to 0 where for the function x divided by 5, and that's equal to 0 divided by 5. So I want you to take the moment now and tell me, put this part in your calculator and keep in mind what you get. Take a moment to do this now. Alright, so if you figured it out by now, the first one is going to be infinity, but the second one is going to be 0. At first that was 3 bags of nopes for me, but after a moment or two I think I figured out why. If 0 is being divided by a certain number, that means how many times 5 can go into 0, but 5 cannot go into 0 at all, so it can't be divisible, so it won't be divided, so you have 0. But where you have 5 equals 0, 5 is being divided by a number you basically can't divide by 0 because you'll get an infinitely large number, and that's how we come across infinity. I'm tired. Alright, number 7. No shorthand. Limit x tends to infinity for the function -3 times 5 plus 4x plus 11. Hold on, that's not 3x. Cancel. That's not 3 times -3 times 5. That's 3x to the 5th power plus 4x plus 11. So we have to do the same thing we did with the last one, where we look for the highest power and factor it out. So here's what we're going to do next. We're going to say limit x tends to infinity for the function. Since we're factoring out x5, we have to say x5 -3 plus 4x 4x plus 11 . But here's what we're gonna do. I should do this simpler. But for the sake of simplicity, we're basically dividing each term here by x to the 5th power. So x to the 5th power disappears from here when we divide it by x to the 5th power. But for 4, it's not quite so. We're gonna erase this x, because there's 1x on the numerator and 5x is on the denominator. What happens is that you'll still see a representation here, but you won't see x to the 5th power, you'll see x to the 4th power because it lost that x. Then you're gonna see x to the 5th power on this side because it had no x in the first place. And then the limit x tends to infinity, we're gonna say infinity to the 5th power multiplied by -3 plus 4 divided by infinity to the 4th power plus 11 divided by infinity to the 5th power. everything here with infinity is going to be equal to 0. So here's what we're going to do. We're going to say limit x tends to infinity for -3 plus plus 0 plus 0. Sorry, that's gonna infinity, because infinity to the 5th power is still infinity, but when divided by infinity, the answer is 0. So we're going to say limit x tends to infinity for the function infinity multiplied by -3, and you know what you get? Negative infinity. And finally, we arrive at number 8. Number 8, limit x tends to infinity for the function x to the 5th power. No. 4x squared plus 9 divided by 9x squared plus 4x. So based on what we just learned, this is basically infinity divided by infinity. So what we have to do here is we have to divide the numerator and the denominator by 1 over x squared. So here's how it's gonna work. So we have, limit x tends to infinity for the function now 4x squared divided by x squared plus 9 divided by x squared, all divided by 9x squared divided by x squared plus 4x divided by x squared. So here's what's gonna happen. These cancel, that leaves 4. These cancel, that leaves 9. 9 divided by infinity to the 2nd power, and 4x, hold on, 1. And 4 divided by x, so we'll now have limit x tends to infinity for the function 4 plus 9 divided by x squared divided by 9 plus 4 divided by x. That equals 4 plus 0 over 9 plus 0 equals 4 divided by 9. And that brings us to the end of our first session. I'd like to thank you for, well, if you made it to this point, which I don't think a lot of people would, but if you made it at this point, I'd like to say thank you for giving me your time. I hope you learned something from this. It was my first class and there was quite a bit from it I didn't too understand, but I'm gonna continue this series whether people like it or not, because this really helps me and I hope it helps others. And I hope over time I'm able to present this in a more unique and interesting manner. But for now, I'd like to give you my thanks and bid you farewell until next time.